I'd like to now look at another example of using our sum and difference formulas in trig functions. On this one, I've asked you to find the cosine of 7 pi over 12. Well, 7 pi over 12 is not an angle that I know necessarily from my basic 30, 60, 90 even quadrantals. So the first thing I'd like to do is convert 7 pi over 12 into degrees. So let's take to the side 7 pi over 12 and I multiply it by 180 over pi to convert this into degrees. Okay, I can cancel out the pi's. 12 goes into 180 15 times. 15 times 7 is 105. And so 7 pi over 12 equals 105 degrees. So let's first rewrite cosine that I originally had of 7 pi over 12 as cosine of 105 degrees. Now, the next thing I'd like to do is I'd like to take 105 degrees and rewrite it either as a sum or a difference of things that I do know. Okay. One way to do this is I could rewrite this as the cosine of 60 degrees plus 45 degrees. If I add 60 and 45, I get 105. 60 and 45 are both angle measures that I know something about. The next thing I'm going to do is I will rewrite this sum using one of my sum and difference formulas. Okay, this is cosine of the sum of two angles. And so the formula I need to use is going to be written as cosine of the first angle multiplied by cosine of the second angle. And then I always use an opposite sign as far as what I was originally given. This was a sum, and so right here I use a difference. And then in my next set, I use sines instead of cosines. So I'll have sine of 60 degrees times sine of 45 degrees. Okay, at this point, I need to draw two triangles out to the side. I'll draw a triangle for 45 and one for 60. And it doesn't matter what order you do this in. So here's a 45-degree angle. I've got 1 square root of 2 as the sides. And I have a 60-degree angle. There I would have 1 and the square root of 3 and then 2. Okay. Cosine of 60 degrees. I want to look at my 60-degree triangle I have drawn. Cosine I know is x over r, so that would be 1 over 2. Multiplied. Cosine of 45 degrees. Cosine is x over r. This would be 1 over the square root of 2 in this case. And then I have minus. Sine of 60 degrees. Sine is y over r, so that would be the square root of 3 over 2. And then multiplied. Sine of 45 degrees. Look at the 45-degree angle. This would be 1 over the square root of 2. Okay, simplify these two fractions together by first multiplying. I'd multiply these two together first. I'd have 1 over 2 square roots of 2, and then minus the square root of 3 over 2 square roots of 2. My next step would be to combine. I already have a common denominator, and so I can combine by saying 1 minus the square root of 3 on the top, and then over 2 square roots of 2 on the bottom. The last step is to rationalize my denominator. I'll do so here by multiplying by the square root of 2 over the square root of 2. On the top, I'll have to distribute. So I'll have 1 times the square root of 2, which is the square root of 2, and then negative square root of 3 times square root of 2 is negative square root of 6. On the bottom, the constant 2 stays, and then the square root of 2 times the square root of 2 is just 2. And then that simplifies to the square root of 2 minus the square root of 6 all over 4. And that's the final answer for the original, what's the value of cosine of 7 pi over 12?